Is it recording now, Steven? Okay, can. Right. Maybe I will just begin with my announcement again so that nobody miss anything. So the announcement is this. Please go to your adventure and check whether the course announcement has been updated to you by email. Basically, this is to indicate the subset of the questions in tutorial orthogonality that will be included in the exam, which is question 1, 2, part 19 ABC, question 4 and 5. For tutorial least squares, you only need to do this question 1, 2, 4, 5, and this small part of question 5. The rest you can ignore. The two links are the same. Oh, yeah, that's right. Okay, I'll update the link. But actually, once you go to the video link, you'll realize that it'll bring you here. You can bring you here, and you only need to go to part tutorial 6 and tutorial 7, which is the tutorial solutions of these two sets of questions. Tutorial 6 is orthogonality. Tutorial 7 is least squares. You can ignore tutorial 8. Okay, so with that, what I'm going to do now is that I will go to orthogonality. And what is orthogonality? So basically, when we have a vector here, let's call this vector u, and then we have another vector here, v. And if they are right angle to each other, we say that vector u is orthogonal to vector v. And of course, this is in 2 dimension. And in our case, we call this R2. And the word R stands for the real number. And here 2 indicates that it is the 2 dimension that we are interested in. Now, typically you also realize that we write vectors in this form. So what does that mean? All right, let's go and understand how we write vectors in at least this course. So we say that u is equals to -1, 2. So basically, you can also think of this as the first element of u1, and this guy as the second element of u2. And what we then do is that we are interested to draw it, because in 2 dimension and 3 dimension, we can draw the vectors. Now, let's draw the vectors first. First, we draw the x-axis and the y-axis. And you realize that the first element will be the element along the x-axis, and the second element will be the element along the y-axis. And since we want to have -1, so we move one element, one coordinate along the x-axis in the negative, towards the negative. So how do we label these guys then? It'll be, of course, this is 1, this is 2, this is 3, 4, and here will be -1, and so on, -2, and of course this is 1, 2, 3. So where is -1 is of course here, and where is 2 is here. So this point is the vector u. So it is -1 coordinate along the x-axis and 2 coordinate along the y-axis, as it here. And then what about v? 4, 6. So to do that, 4, 5, 6. So we need to draw it until here. So this is 6, and here is 4. So that this point is 4 along the x-axis, 6 along the y-axis, and we call this v. So now we know how to draw a vector, 2-dimension vector along this Cartesian plane. Okay, so immediately we then want to ask very standard questions, uh, and let's answer maybe this kind of question first. Question 7. What is the norm of V? So these two bars here, this is like length of, then whatever the the vector is V in this case. What is the length of V? So the length of V is this length over here. So I'll highlight for you. Is this length. How long is this length? And you know that, hey, this guy is a, what do you call it, a right angle triangle. So all you need to do is to use the Pythagoras theorem and find the length. So the length of this guy is 4 coordinates. So it's what? So you u1 square, right? 4 coordinates square plus 6 coordinate along the other guy, u2 square root, right? So this is the Pythagoras theorem. Question, yeah, correct. Yeah, I'm because I draw so I'm not doing question 7, I'm drawing question 9. Let's see. I'm just interested in norm of V. I don't want to do norm of W, okay? Sam? So question 9, let's see. Norm of V is, so now I'm drawing this guy. So of course then it's very easy. So all we do is we plug in u1 is 4 square plus 6 square. So it is, then of course it's 16 plus 36. And then you can work out the math, which is 2, 3, 4, 5, 52. Okay, so that's the idea of answering this kind of question, the norm of. All right, so I'm going to answer another question. Another question that I have is, u dot v. Okay, so I'll erase this first. So if you ever seen this guy, this, so u, I mean, if you want to read this, is u dot v. All right. And then if you want to calculate this, uh, well, there are actually multiple ways. So I'm going to tell you the ways now. Let's first first of course is I must tell you what is the dimension of u. So in this example I have is guys, please help to answer. U is an element of what? What am I going to write here, guys? Can someone help me to answer, please? Z. Not Z, because Z is integer. It belongs to R, which is real. And R, what number will I put here, guys? R what? 2. Very good. R2, because you see, I am a vector U that has 2 elements, R2. So, of course, I should write R2. Okay, so U is an element of R2. And then, of course, then V is also an element of R2. That's why they are both elements of R2. That's why they can dot together. Why? Because to dot something together, there are 3 equations. I'm going to tell you the first one. So U dot V is defined. Defined basically means the math guy tells us this is how we're going to do it. U V cosine theta. So what is this equation? This one you know. This is the length of U multiply. So here it got nothing between here. So it's length of U multiplied by length of V multiplied by the cosine theta. So what is theta? It is the angle between U and V. So where's the angle between U and V? So we have V here and we have U here. So the angle between them is here, this guy. So I'll use a different color now. And here is theta, the angle between this guy. So we not normally, we always choose the angle that is less than 180 pi, huh? Because you could have, I mean, you think that you could have chosen this angle, but no, we always choose the angle that is less than pi. All right, so this is one way to calculate u dot v. There's another way. So u dot v is also equals to summation of u I v I equals to, now this, what, remember this is only u1 and u2, so I is only going from 1 to 2. So of course this summation is looks very complicated, but actually it's nothing but u1 v1 for the first guy plus u2 v2, right? So in fact this is very easy to calculate. So let us do this. What is u1? u1 is minus 1. What is v1? V1 is 4 plus what is u2? 2. And then what is v2? 6. And the answer is minus 4 plus 12 equals to 8. Finish. So in fact, then you'll be thinking, what about this guy, right? So when you realize that this guy, of course, must be also be the same number, 8. Now, if you understand that this equation produces can be calculated by this equation, and since we got 8, then it is very easy now to calculate theta, because to find the length is easy, to find theta is hard. Okay, so u dot v can be used to find the angle between two vectors very easily. Okay, now one more way. So the third way to calculate u dot v, does anyone have any idea? In fact, this equation, right? This equation tell us how to do it in the third way, the vector multiplication way. So I'm going to write it as u dot v is equals to, I'm going to write u transpose v. And what is u transpose? U transpose is a vector that looks like this, u1, u2. It becomes a, you remember, I'm writing a vector as a column vector. This is a column. U transpose has become a row vector. See, I make my column become a row, and my V is still V1, V2. Now, a row, this guy is 1 by 2, multiplied by a 2 by 1, becomes a 1 by 1, which is a scalar. So how does it look like? It becomes U1, V1 plus U2, V2. Exactly the same equation as here. So now you see there are 3 ways to write u dot v. Okay, the first way is norm of u, norm of v cosine theta. The second way as a summation of all the elements product. The third way is u transpose v. And all the answer is the same, whichever way you can find. All right. So I will let you work out cosine theta, and of course you can go to a graph and measure this. I don't know how many degrees is this, but you can work it out. Any questions, guys? Okay, can. So if you have no questions, then let's go to some more the other. So we have done at least question 1 now, right? U dot v, v dot u, and things like that. So maybe I would now ask you, do you think v dot u? So I've done u dot v. What do you think about v dot u, guys? Oh, cosine theta. Okay, cosine theta. All right. Okay, can I erase this first, guys? And then I'll talk about cosine theta. Okay. So let's Let's erase this first. And I'm gonna change this diagram to something simpler. Okay. Okay. Let me just erase those all. All right. Okay. Let me give you an example that is easier to understand. Let's have a vector called V that is 1, 0. So it is 1 along the horizontal x-axis and 0 along the vertical axis. So I'm just drawing it on the axis. And the other guy is going to be U, which is equals to 2, 2. Now, let me ask you about angles. Theta. Can you guess what is the angle between U and V? 45 degrees, correct. So theta is equals to 45 degrees. But we don't like to write uh, angles in degrees, okay? So please use radian. So, so remember, now let me revise for you a basic angle. So this is 45 degrees. And 45 degrees is equals to how many? So if you guys don't remember, please remember what is 90 degrees. 90 degrees is how many pi? Correct. Pi by 2. So therefore, 45 degrees is pi by 4. Okay. And of course, then when we have 180 degrees, it is equals to pi. All right. And then, uh, so we are most interested in pi by 4, pi by 2, pi. And then, of course, this guy is how many pi? This guy is 180 degrees plus 90 degrees is equals to 270 degrees. And 270 degrees is, so you think, it is pi plus 90 degrees is pi by 2. So it is 3 over 2 pi, right? That's it. And of course, then we have one more, of course, 360 degrees. 360 degrees is what? It's 180 plus 180, which is pi plus pi, right? So this is in radian, and this guy is in degrees. So in our course, please use radian. So you must punch the radian and then you use that. But first, if you want to use degrees, fine. All right. Okay, so let's do this together, guys. And what about U dot V? So among the three methods that I have shown you, right, which is the easiest? You realize that in the simplest case, the easiest one is to use this guy. Okay, so let's try. U dot V is equals to, if you can do summation of UI VI. So it's equals to 2 times 1 plus 2 times 0. Correct? It's the first element of U times the first element of V plus the second element of U times the. So the answer is 2. Okay. So this is U dot V. So let's try the other method, which is U dot V is equals to U transpose V. So U transpose is 2, 2 multiplied by 1, 0. So again, this is, so you take the first row, multiply by the first column, then you get 2 also. And then the last method, U dot V is equals to, U dot V is equals to what? Norm of V, cosine theta. Now, we know cosine theta, right? So this cosine theta is pi by 4. So norm of u is what? The length of u. So it is, guys, is it safe? Wan Chin asked me, is it safe to always assume the angle is always pi over 4? No, 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 no. The depending on no, no, no. The angle is really the real angle between two vectors. Okay, so I give you an example. If I give you one vector here and one vector here, this guy is definitely not. I mean, oh, it looks like pi by 4, but let's change this. So this angle is definitely not pi by 4, right? It's very small angle. Okay, so please don't assume. Yeah, the reason why we use such simple angle is just for our, so that it's easier to calculate. But it can be any angles, yeah? Anything between 0 to pi. All right, so what is norm of u, guys? Norm of u is the length of u multiplied by the length of v times cosine. Then we put in pi by 4. All right, what is the length of u? It is the Pythagoras theorem. We use what? We're going to do 2 here along the x-axis, two squares, right? So it'll be 2 squares, 2 squares. Then it will be up by 2 squares. So the two sides, and then we square root. So this is the length of u. What about the length of v? The length of v is easy because it is actually only one unit. So it's 1 square plus 0 square square root. So it is times 1. And then cosine pi by 4. Okay, now guys, I'm going to pull out my calculator and then I'm going to show you. Okay, so what you guys need to do now is you guys go and try. Okay, so this is square root of 4 plus 4 is 8. Square root of 8 multiplied by 1 cosine pi over 4. So I'm going to work it out, and let me erase this first. And then I'm going to write it here. Okay, where's my MATLAB? Hmm? Here. All right. So you can see I'm just pulling out a calculator. So what do you think? So let us try to remember uh, cosine. What do you think is cosine of 90 degrees? Can you all type in the chat, please? What is cosine 90 degrees? 0. So, so should I do cosine 90? Do you think it's 0? It's not. The reason is because MATLAB uses radian. So this is some numbers. So instead, I should do cosine what, guys? I should do cosine pi by 2. Very good. So pi by 2, and it is some number to the power of minus 17, which is 0. Okay. Okay. All right. So I'm going to do cosine pi by 4. 0.7071. This should be a very uh, number. So this guy is 0.7071. Now, what do you think this number is? Hmm? It is actually 1 divided by square root of 2. Okay. Now, so I have square root of 8 multiplied by 1 multiplied by 1 over square root of 2. What's my answer, guys? So it's square root of 8 divided by square root of 2. So it's square root of 8 divided by 2. Square root of 4, and the answer is 2. Same as what we got below. See? 2 here, 2 here. So it used 3 different methods to find u dot v. Okay? And now, I hope I have answered your questions. What is cosine theta? and how to calculate this from this example here. Any questions? So in the exam, I can give you, I can give you two vectors, and of course I can ask you to find u dot v, v dot u. I can ask you to find the angle between them and things like that. U transpose v equals to 2. Oh, okay. All right. Let me erase this first. Okay. All right. So the lady asks, u dot v is this sign, u transpose v. What does u, what is u? Remember, u is a vector. In our case, is a column vector that is R2. So u is this. This is u. What is u transpose? It basically means this is a column vector. Let us make it into a row vector. So this is u transpose. What is u transpose v? It means u1, u2. So this is u transpose, right? This guy is u transpose. And then this is v1, v2. So now this is a vector. This is a row vector. This is a row vector here. And this is a column vector, right? So you're now asking, I look at this and how am I going to get out a number? So first is you must remember this row vector is 1 by 2. So we treat this as a matrix. You think of it as a matrix, 1 by 2 matrix. And this guy is a 2 by 1 matrix, right? So out will come a what? 1 by 2, 2 by 1. These two guys agree. Okay, so the output is 1 by 1. What is 1 by 1? It's a one single number. It's a single number output. So it's a scalar. So this is talking about the size. And the operations that will be carried out is we'll take this u1 will multiply by this v1. And then we'll now take u2 multiply by these two and we sum. So the operation is actually u1, u1 v1 plus u2 v2. So now I color code for you. So this is pink. And the other guy is green. Can you see? So u1 v1 plus u2 v2. And then this is a number plus a number. So out comes a number. So to my, have I answered you what is u transpose v means? Okay. So when you are playing with this, you realize that what is this? This is nothing but this is I'm doing matrix multiplication actually, yeah. Because this is a row vector multiplied by a column vector. This matrix is 1 by 2. This matrix is 2 by 1. So we can multiply it together. You're welcome to my. All right. So I've done these few questions. And you realize that in the videos, the video links that I have sent you, I answer them, all of them. But remember that in our announcement today, only a subset of them is needed. Okay. All right. Let me now answer another question here. Okay. Yeah, please keep the questions coming so that it'll be useful. So maybe I should I'll do question number, I'll do the simple one first. Okay, I'll do this question. All right, and so let's do it together. U dot V divided by V dot V. V. So this is question number 5. Now, guys, please help to answer this. What do you think will come out from here, the top? The dot product of u dot v will come out a what? No. It will come out as scalar. Do you all know what a scalar means? A scalar or a number, okay? It will come out a number, a real number. U dot v, yes, is a magnitude with no direction. Very good. U dot v is a scalar, a number. Multiples? No, a number, a single number. U dot v, remember we were playing with u dot v, come out at 2, 3, 4.5, whatever, a number. Yes, it's a 1 by 1 matrix, which is a number. Very good. And this guy below, the green guy, also a scalar. So it is a scalar divided by a scalar is again a scalar. And a scalar multiplied by this guy is a vector, right? Which is element of R2. It will come out a vector. Okay. So let's try. U dot V. Let's do the simplest U dot V. Remember, there are 3 ways to do U dot V. We'll always use the simplest. U dot V is equals to, I will just write -1, 2, 4, 6. So I'm writing it as U transpose V. And this is, of course, -4 plus 12. And the answer is 8. So the top number is 8, U dot V. V dot V is 4, 6, 4, 6. And the answer is 16 plus 36 equals to 52. So this guy below is 52. So therefore, U dot V, V dot V is equals to 8 divided by 52. And the answer is, what's my answer, guys? Oops. Oh, okay. Divided by 4 is 2. Divided by 4 is 13. So it's 2 over 13. All right. So I have 2 over 13 for this. I'm going to shade this all yellow now. So this yellow is this guy. 2 on top, 13 below. So I should shade this as green. So it's 2, 13. All right. Now multiply by 8, 13, 12, 13. Hazel, did I make a mistake, Hazel? 2 over 13. Correct, huh? Okay. So why does U dot V becomes a scalar? U dot V, oh, remember? U dot V is this equation, right? It's a U transpose V, right? Legs, yeah, okay. And this is a 1 by this vector is 1 by, oops, this guy is 1 by 2, right? And this guy is 2 by 1, yeah? So when we do this matrix vector multiplication, out comes a scalar. So U dot V is always a scalar. Okay? Now, understood, cause it's a single number. Yes, correct. So now I have to deal with the last guy. So U dot V over V dot V multiplied by V. So I'm going to write it out for you. Is 2 over 13. Then I have to write V. What is V? 4, 6. Agree? And in fact, you can stop this as the answer, or me, I will stop this as the answer, right? Unless, what can I deal with? Oh, that's, I mean, if we write 8 over 13, 12 over 13, what do you mean by 8 over 13, 12 over 13? 2 by 13 times 4. Give us 8 over 13. I don't understand. Hazel. You're Hazel, you're talking about this number, the final this number. This number is no, it's 8 over 52. When we divide is 2 over 13, I think, right? It's not 2 over 13 multiplied by 4. Oh, you're talking about this guy, is it? Ah, so yeah, we want to live with the V, right? So that we can see V. It's good enough. Yeah, we want to see the scalar multiplying by the vector. So the scalar is u dot v divided by v dot v. All right, then you must be wondering, what does this shows? What does this shows? Okay, to do that, I'm going to erase this, and I'm going to what does this show? Okay, I'm going to draw uh, uh, okay, I'm going to draw two vectors, and then I'm going to ask you to imagine. 2, 4, 6, 8. Okay. The first, all right. This is 2, 4, 6, 8. And this is 2, 4, 6, 8. Now, please work with me. This vector is called U. So U would be what, guys? Again, U is an element of R2. And it has two elements called U1 and U2. And now I ask you, what is the element value? Please answer. 4, 2. Excellent. So 4 along the x coordinate, horizontal coordinate, y. So it's 4, 2. 4 along here and 2 up. Very good. And now I have another guy. What about this guy? Okay, I have V. Y. Okay, let's change. Y equals to, guys, what's the answer? 7, 6. Very nice. 7 along the horizontal axis, 6. And now, what do you think so now the question is projection. Oh, sorry. The projection, oops, the projection of y onto u. What is the projection of y onto u means? It means let us use u to approximate y. So how would you do that, You're like, okay, so I repeat. The projection of y onto u is the idea of we are saying, let us use u to approximate y. Let us project y onto u. So to project y onto u is we extend this. Pa, 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 pa. Oh, this is not very straight, but okay. So you get the idea. This is the extension of u to from the bottom to the top as a one straight line. So we want to project y onto u. So if we say that, hey, I'm going to use u, any scalar multiple of u, that means I can make him longer or I can make his direction inverse, but I can only go into this direction. What do you call it? You know, what value? Should I land here? Should I land here? Should I land here? Land here? Land here? Land here? Land here? Land where? Where should I land so that the projection of y onto u is the what do you call that? The nearest value of towards y. So maybe I should show you that intuitively you will think that it should land somewhere here because it cannot be here because it is so far away from y, right? So the idea is that it must be somewhere here, but how? You know how? And you realize that actually the idea is that the error, right, is orthogonal. The error here, call this E, will be orthogonal to this vector here. And this vector here is called the projection of y onto u, which is the nearest point along what, guys? Along where? The direction of u to y. So projection of y onto u is a vector along the direction of u that is closest to y. And guess the equation is y dot u divided by u dot u multiplied by who, guys? Who do you think I'm? Projection of y onto u is a vector. U. Okay, let's try. Y dot u. Y dot u is 7, 6. U dot u is 4, 2. So this guy is the top. So I will shade for you again. So this is the yellow. So this is holding the yellow. Now I'm going to divide by u dot u. I will use the green. U dot u is what? U dot u dot u is who? It is u dot u is 4, 2, 4, 2 multiplied by 4, 2. And then holding, what is u dot u? 4, 2. All right. Okay. So I will shade this guy. Oops, wrong shade. Okay. Now let's work out the sum. 7 times 4 is 28. Oops. Plus 6 times 2 is 12. So the top number, 4 times 4 is 16 plus 4. Multiply by 4, 2. Oops. And the answer is 28 plus 12 is 40. 16 plus 4 is 20. 4, 2. Oops. And the answer is equals to 2 times 4, 2 equals to 8, 4. And let us see. Is it 8, 4? Oh, almost. 8, 4. Right? So now you realize the intuition, drawing here, just by, a rough sketch, shows that this is the way that we are going to find the closest point along u to y. So where's the key idea? The key idea is here. We are going to use u, the direction of u, and we are going to multiply by a scalar. And this scalar is going to tell me how long this vector is multiplying by the original u to get this guy. Do we need to draw a graph for similar question in the exam? If the question asks you, of course, I mean, you can only draw it from 2 dimension up to 3 dimension. If the numbers given to you is 4 dimension, you can't draw. But when it's 2 dimension, it's very easy. So the intuition, the drawing will agree with the numbers. All right. Now, what did I tell you? I show you that this is orthogonal, right? Who is orthogonal to who, guys? E, what is E? What is the number E? What is E1, E2? How would I find E1, E2? So you remember this is a right angle triangle. Huh? So it's this vector plus this vector equals to y. So therefore actually y is equals to who? The this this vector projection of y onto u plus e. Therefore, e is equals to y minus projection of y onto u. What is y? 7, 6. What is projection of y onto u? 8, what? 8, 4. And therefore, this guy is minus 1, 2. Why is e minus 1, 2? If you look here very closely now, e goes left by 1 unit and goes up by 2 unit. You look, see? It goes to, from 8, go to the 7 by 1 unit. So it's minus 1 and go up by 2 units. So it's exactly E. Oh, okay, great. So now we figure out what is E. And then maybe in the last 2 minutes, I will show you. E is orthogonal to who, guys? Who is E orthogonal to? Can you all answer, please? E is orthogonal to who? U. Very good. E is orthogonal to U, or also orthogonal to this guy. So E is orthogonal to U. So how do I prove E is orthogonal to U? E is equals to minus 1, 2. What is U? U is equals to 4, 2 in this question. So let's try. E dot U is equals to minus 1, 2, 4, 2. Answer is minus 4 plus 4 equals to 0. Voila, right? And we know. So when two vectors are orthogonal, the dot product. So now this is the key idea. When two vectors are orthogonal, their dot product equals to 0. Okay? Now, let me ask you. Is E orthogonal to the projection of y onto U? Quiz question. Yes, no? I repeat. E is orthogonal to U. We have just shown it. Is E orthogonal to the projection of y onto U? Yes. Very good. So let's prove it to ourselves. E is minus 1, 2. This is E. Projection of y onto U is, what's my number? What's my number? Projection of y onto U. Projection of 8, 4. Okay. 8, 4. And this again, this is E, and this is projection of y onto U, and the answer is minus 8 plus 4, 0. So actually, you realize that this guy is orthogonal to any vectors along U. Can you see? Whether U is pointing this way up or this way down or things like that. Can you see? Doesn't matter. What is minus 8? Shouldn't E? 8, 4, 8, 4. Correct, 8, 4. All right. So now I'm at 8:21 now. So we have 6:30 to 8:30, right? Okay. Your teaching is excellent. Better. Oh, okay. Uh, thank you, Dix. Mm. So, so, so you notice that I'm here in question 1, but I'll now show you, what do you call that? I'll now show you, uh, so if you go to the link, you'll realize that this is the course. I'll explain the overview of the course so that you that you guys will, what do you call it? You guys will navigate. So part one of the course is what some part of Professor Deepu's course. This part one and part two is for a 13 weeks course in linear algebra in undergrad in our school. What you guys are going to do is only about 1/3 of the course. So in your part of the course, my part is chapter 6, which is orthogonality. Chapter 7 is least squares. Chapter 8, you're not interested in, so forget about them. So you can go to chapter 6 and only view some of the materials you do not need to have. It's possible to have an answer sheet for all the questions. Yes, in fact, I released all the answers in here, tutorial 6 and tutorial 7, as well as, if I'm not wrong, I think I also give you all the answers here, right? In my zip file to you, I release all the answers. Yeah. And if you don't want to watch the videos, you just see the answer. But today, what I tell you is that uh, you only watch. Sorry, some of the questions not all the questions are in the syllabus. Yeah. So this is the key idea. These are key new information I given you, because I realize that you all don't do subspace, so you don't want to do that. Okay. So now, so uh, uh, Tumai has a question. Yes. So Tumai's question is why when two vectors are orthogonal, the why when two vectors are orthogonal, the dot product is 0. Yes, yes, that's right. That's right. So in fact, you realize that the E vector is 90 degrees to the U that direction vector. And the angle between them is 90 degrees. So remember that we have three ways to calculate E dot U. Okay, so now I'm going to write here. So let's erase this first. Oops. E dot U. Remember three ways, okay? Three ways. The norm of E, the norm of U, cosine theta. The second way, summation of EI, I equals to, in this case, 2, which is E1, U1 plus E2, U2. The third way is E transpose U, which is E1, E2, U1, U2. Right. You use three ways to calculate this. Choose the simplest way. Typically, when all the values of E and U are given, you use this way, the easiest way. Because then you think, hey, since these three answers are the same, this guy cannot be 0. This guy is not 0 because they are real vectors with length. So cosine theta must be 0. When is cosine theta equals to 0? Only when the angle theta is equals to, and what this Tumai has said, the angle must be 90 degrees. So when angle is pi over 2, 90 degrees, cosine 90 is 0. Okay, Tumai? Did I answer your question? Yes, good. How to understand projection of y onto u? Eh? Okay, so this picture, projection of y onto u, what does this look like? It must be a vector along u, right? And we have the idea of projection of y onto u is, it's just like you are looking, your eyes is here, and you are looking here, and you are saying that I want to cast a shadow of y onto u. And this is the shadow. This is the nearest point, and you make the eyes 90 degrees, such that when you cast the shadow, this will be projection of y, the projection, right? Project, I want to project y onto the surface of u, which is a line. Okay, Montiano? And then I still want to make him the nearest point. So I must make my eye 90 degrees to the line of u. Okay? And then this point is the nearest point that I can ever make my projection of y onto u, or I mean, if you make a point here, you're saying, I'm so far away from y, right? It's hopeless. So this point is also hopeless. This point is also hopeless. Until this point, ooh, nice. This is the nearest point. Is it? It is harder to visualize in 3D. Yeah, of course. Very, very hard. So we always draw R2. Okay. And then, in fact, in R2, how do you prove that this is the nearest point? It's because of Pythagoras theorem. So have I answered your question, Montiano? Hmm. Still a bit confused. Projection of y onto u. Okay, let me try. This is u. Easiest, huh? This is y. So what is y? 2, 1, right? Agree? And u is, this is u. Sorry, this is u. U is 1, 0. Agree so far? Can? This is the x-axis. This is the y-axis. Okay, Montiano? All right. I want to find, find a vector along u nearest to y. So where can you go? You can run around here. Ooh, that's bad, right? You're running further and further away from you. You run here, oh, slightly better because you are nearer this to here. You run here, nearer. You run here, you think, hey, very nice, almost the nearest. You run here, further away. Can you see now? You're further away from y. So the nearest point of the nearest point along the u direction to y is such that this arrow vector, the arrow vector is going to be orthogonal to u. And this point here is the projection of y onto u. And it is given by y dot u dot u times u. Okay? So, to, no problem. Okay, so this is the real, I mean, if you are in the 2D, you can see this. I mean, you guys can try, you can try to find a point here, point here, point here. Until when you find exactly here, it's going to be the nearest. Will the projection formula be provided? No. So you guys have a one-page cheat sheet. You write down all the formulas you want and bring that page with you. Remember, uh, Professor Adams Kong has already tell you that you can bring one-page cheat sheet. And in our undergraduate students' case, they are also bringing one-page cheat sheet. Is this formula fixed? This projection? Yeah. It's this way. And the dot product is that 3 equations I show you, the 3 ways. Yeah, oops, I've already erased them. Yeah, this way. The 3 ways to find the dot product. One page or 2 page? One piece of paper, 2-sided. Please don't bring 2 page. One piece of paper, 2-sided. You can write, you can type. Prof, so for one question each for the quiz for orthogonality and least squares. Oh, okay. Don't worry about how many questions there are. Uh, uh, there'll be a small part from orthogonality and a small part from least squares. Okay, when to use as a column and when to use as a row vector. Okay, all right. Uh, in cases when we say u, and we say it's Rn, we are always writing it as U1, U2 until Un. And this is always a column vector. And here, column vector with real numbers as element, as entries, and there are n entries. Okay, so that little Rn means I am a column vector. Each of these elements is a real number, and there are n of them. So we always write as column vector. So when do we write it as row vector? We say U transpose. Then suddenly it becomes U1, U2, Un. Okay, so that's the idea. So Donald, have I answered you column and row? Do we require to read the lecture notes? Seems more. uh, no, okay, Samuel, you can you can read the lecture notes. You can watch the videos. You can read any books. Everything is the same. I mean, maybe I have explained it differently. Uh, yeah. Okay. Uh, question 1219 ABC. Okay. So let me show you. Where is it? Oops. Where am I, guys? So let me get out here first. Okay. Tutorial 6, right? Tutorial 6, question 19. Question uh question 2, right? Oops. Okay. Mm. Question 2, is it here? Yeah. So what you do is this, you go to this remark column, and you see that I've explained all this, and then you can just jump very quickly. Okay, so go through this, and if you do not know, next week when we start, I can answer these questions for you again. So what I do is that instead of going very fast, I will actually just explain it very slowly, and then yeah, some of them you do not need to know. In fact, we realize that we want to include null space, column space, so some of the questions are not included. Okay, any other questions, guys? Okay. Okay, I think I'm almost done, so I'll just stop sharing now. Okay. Okay, guys. Right. So I'm almost done. If there's any question, what I'll advise you to do is you can send me an email, and my full name is Chung Eng Seong, and my email is, what do you call that? Send to everyone is this, and aseschung@ntu.edu.sg. Do you have fits on calculus? No. I only teach linear algebra for our school, and so you see that this is the recording I have taught. Next Tuesday again, yes. Please see the link in the, what do you call it, in the adventure, in the thing I've given to you. So what I'll do is that I will stop the recording, and I will try to post this recording and put it somewhere, then you guys can download later on. Okay? So then, yep, no worries. Thank you, and have a good evening, everybody. Yeah, thank you. Goodbye. Good night. You can omit the notes and focus on the tutorials, but you realize I only done tutorial the first question, right? In fact, there are 5 questions. So I realized that to help you all, I rather do the questions in great details and everybody understand it at this time. Okay, can. Thank you. Good night. Happy you understand.